are going to continue to be the same. Substitution and elimination. These problems are going to be a bit longer because I'm going to have more variables to solve for, but the process is the same as we've done before. What our strategy will be is to take two equations at a time and work to eliminate a variable in that. So let's look at a problem. I'll give you a second to write that down before I start. Always check to see if all the equations actually include all three variables. If one of the equations only has two variables in it, that will make our work a lot easier. This problem, we don't have that advantage, so we are going to have to work with all the variables at once. What our goal needs to be is to pick two equations and eliminate one variable. And then we're going to use the third equation and eliminate the same variable. So pick a letter. What do you want to get rid of in all of these? Z. Okay. If I took the first two and I wanted to eliminate Z, what would we have to do? Okay, so let's do that. If I take the top one times 2, then I get 2x plus 2y minus 2z equals negative 2. And 4x minus 3y plus 2z equals 6. When I add these together, my z's drop. 2x plus 4x will be 6x minus y equals 14. Are we okay with that? Now we have to look at the equation we have not used. I haven't done the third equation. So I need to go to the third equation. I need to eliminate z as above. Which of these do you want to pair it with, the first or the second? The first? Okay, so let's take the first and third. What are we going to have to do this time? Top times negative 3. So that's negative 3x minus 3y plus 3z equals 3. And then we have our third equation. So first I did the first two and eliminated z, then I did the first and third and eliminated z. When I add these together, I get negative x minus 5y equals 8. Alright. After this point, the problem turns into a lot like we were doing a few days ago. If I have two equations, I'm looking right here, these are two equations, they both have an x and a y in them. So I want to put those two equations together and eliminate a variable. What do you want to cancel, x or y? X. Okay, if I want to cancel x, what do I have to do? So I'm going to keep this equation, 6x minus y equals 14. If I take that one times 6, I get negative 6x minus 30y equals 48. My x's drop, so I have negative 31y equals 62. Divided by negative 31 and y is negative 2. before I go any further, do you have questions to this point? So we worked to get rid of the z. Then we had two equations with both x and y, so we put those together and eliminated x. Now I have my y, so now we can just work backwards and get all of our answers. Once we have y, we just have to plug it back in to get x. Let's plug it in to one of these. Okay, so if I put it in right here, 6x minus negative 2 equals 14. 6x is 12, so x is 2. So x and y are both 2, and now we can get z. We just have to go back to the beginning. Or sorry, x is positive 2 and y is negative 2. So if I plug those in, let's say to the first one, I would have 2 plus negative 2 minus z equals negative 1. So negative z equals negative 1, and z is positive 1. So I have x, y, z. When you go to write your answer, we are going to do, in this case it's an ordered triplet because there are 3 variables, you just go alphabetical order. So x, y, z. How can you check yourself? Plug it back into the originals, all 3 of them. It should work for any. You ready for another one? Let's go to this one. Yeah, I mean it doesn't, I was just lining up, that last equation doesn't have a z in it.
So it looks like the two z's already canceled from the before.
Yeah. If we look, this third equation is already missing a z. So it'd probably be the easiest just to cancel z in the first 2, right? It would save us a step. Now, to cancel a z in the first 2, we aren't even really going to have to do anything, are we? They already cancel, so we're just going to be able to add those together. So in other words, we're taking these equations, they're already opposites, so we don't have to multiply by anything. When we add together, we get 3x plus 2y equals 3. Now I have to take this and this and put them together. 2 equations that both have x and y. So if I want my x to cancel, what do I need to do? Alright, so let's just take this one times negative 1. So I get negative 3x minus 2y. My x and y both cancel, so I'm left with 0 equals negative 3. What does that tell me? And we also write inconsistent.
Is that just for what? For x?
If at any point you get a false statement, a If all your variables cancel and you have something that's true, then the whole thing just becomes inconsistent. There's no ordered code that would make this true. Let's look at in order to get an answer, like a number answer, you will have to have the same number of equations as you do variables. If I look at this, I have 3 variables but only 2 equations. So I am not going to be able to get a complete answer to this. However, if I look at the directions, it tells me to solve in terms of x. So that means my answer for my ordered triplet, I want all of these expressions to be in terms of x. So the x will stay, but I have to figure out something for y and something for my z. So I need an equation for y that only has x as the variable. What could we do? Subtract our 2x because we're trying to solve for y. So y is 4 minus 2x. So I solve for y, the x is the only variable there, so that's good. In this one, it has x, y's, and z's. I need to solve for z, but I don't want any y's in there. So I can replace my y with the 4 minus 2x. Okay, so we had to get rid of the y, we're just substituting in there. So I get x minus 8 plus 4x plus 3z equals 7. We are trying to solve for z. So I'm going to combine my like terms. I'll go ahead and just add my 8 over. So subtract my 5x and divide by 3. So z is 15 minus 5x over 3. So that's my equation for my z.
You would not split the 5.
You can, it doesn't matter.
I didn't know.
Yeah, it shouldn't matter how you write it then, as long as it's in lowest terms. Okay. So sometimes we can still get no solutions on these. We can still get infinite solutions, like this. If that's the case, I will tell you which variable to write everything in terms of. Let's try one of our problems from yesterday using this. So one of our application problems. An investment of $35,000 was made by a business club. The investment was split into 3 parts and lasted for 1 year. The first part of the investment earned 8% interest, the second 6%, and the third 9%. Total interest from the investments was $2,610. What are the things that I don't know here?
They have not invested interest.
Okay, so word problems you have to define your variables. So I'm going to say x is the amount at 8%. Y then would be my amount at 6%. And z Okay, let's see if we can write any equations yet. The first thing I knew is that we had $35,000. So what would that mean? Okay. We know the total interest was $2,610. We had some interest problems yesterday.
0.08 plus 0.08x plus 0.06x or y plus 0.09z equals 116.
Alright, I have 3 variables, that means I need 3 equations. The last thing I have is the interest from the first investment. So the interest from the first. X is my first. To get the interest, you had to take that times 0.08, right? That would be the amount of interest. Was, that's the same thing as saying it is, so that means equals 2 times the interest from the second. What was my interest from the second? 0.06 y.
Wait, so that's the third thing.
Okay. So, now we have to figure out how we want to solve this. We can do substitution, we can do elimination, lots of possibilities. Give me your thoughts.
Substitution.
Substitution. Okay, let's start with the last one. It only has 2 variables. Could we easily solve for one?
X.
Okay, so I know 0.08x plus 2 times equals 2 times 0.06 would be 0.12y. So you said solve for x. So if I divide by 0.08, 0.12 or 0.08.
2/3 or 3/2.
Okay. So x is 3/2y. So now we can substitute that into the first 2 equations. So the first one, I would have 3/2y plus y plus z equals 35,000. 3/2 plus 1 would give me 5/2 y plus z equals 35,000. Combine our like terms. If I plug this into the second one, I get 0.08 times 3/2 y plus 0.06y plus 0.09 z equals 2610. So 0.08 times 3/2 plus the 0.06, if I'm combining like terms, I get 0.18. Ran out of space. Okay, I have 2 equations with 2 variables now. What would it be easiest to eliminate?
Z.
The z. What am I going to have to multiply by? Negative 0.09. So 5/2 times negative 0.09 would be negative 0.225y minus 0.09z. 35,000 times negative 0.09 would be negative 3150. Okay, so if we add, we get negative 0.045y my Z's drop. Equals negative 542. Then
Wait, why is it negative 540? I got a negative 540.
um
Oh, no, it's 542, I thought it was a Z.
yeah, it is a, I don't know why I wrote 542. That's 540. So then to finish it, we just have to divide. And that gives us 12,000 for the Y. Okay. If Y is 12,000, I'm going to be able to find my X really quick because we did substitution. X is 3/2 times 12,000. And that gives me 18,000. So then if you plug those in, X plus Y plus Z is 35,000. So Z would be 35,000 minus those. And we get 5,000. Since it was a word problem, we write our sentence, so the business invests 18,000 at X was the amount at 8%. 12,000 at Y was 6%. And $5,000